Number 7, this is one of the questions we did from the word problems. We had two airplanes kind of flying towards each other, flight 104 and flight 217. I drew the triangle. Basically, I want to know how far apart the planes were, and I know that they're flying towards an airport, and so we know that the distance for each plane is this distance to the airport. We also know that the planes themselves, the altitudes, and that's a perpendicular distance from the ground to the plane, is 2.5 miles. That's on both sides. We were given angle measures in degrees and minutes, so we have to remember how to convert that back. So 17 plus 47 over 60, get 17.78, and then we do the same thing for the other angle. This gives us one angle here, another angle there. It gives me the only side length that I have really is this 2.5 miles. So that's going to have to come into place somewhere. So I'm going to have to use this to get either this side or this side so that we can eventually find this side. Which also brings us to the fact that I need to get the opposite angle measure, which is nice because I have two angles already. So the second step would be to take 180 minus the sum of the other two, which tells me that this bottom angle is 149.57. The next part would be to take sine. So I'm really looking at this right triangle here. And I'm looking at the sine of 17.78 over 2.5 over the hypotenuse y. I realize that this line and this line is parallel. So when you draw this line through it, you have alternate interior angles as well. You could also draw this 2.5 kind of in the middle here. That would have been okay as well. I'm going to solve this equation for y, which gives me 8.19. That becomes my y value here. Now we're left over with just from the right triangle we had here, we have now a traditional triangle. I have a matching set of sides and angles, and I have an x and I have an angle over here, which brings us to the fourth step, finding and solving for x. So plug in the information that I found, and we solve it just like this. That gives us the 18.93 miles is how far apart these planes are. Number 8. This should look extremely familiar because this is the same problem we did earlier when we were working with solving systems of equations. We had tangent set up, we had to substitute one to the other, solve for that, then plug back in. It was a really long problem, and I had mentioned to a few of you that I'm going to be able to do this very quickly if I knew something else, and here we are. So we got the same setup. We want to try to find out how tall the mountain is. We know that one person walks 1,200 feet closer, and we know the angle is 35 to start with and 42 here. That's what we start with. We know that, number one, I can find out this angle because I've got a little tiny obtuse triangle here that if I can find this hypotenuse, then I can just use SOHCAHTOA, the common right triangle stuff, to find out the height of the triangle. And so I need to find this angle and this angle so that I can work out the opposites here, and then the 1,200 is what I'm really focused on because that's the one side length. So I need to get this angle up top, which is why I need this one. So we said 180 minus 42 is 38. Then we're going to add the other two together and subtract from 180 to find the missing side at the top. Right, I've got it here. Which brings up the law of sines question. I'm going to have x, this part, over the 138 here. And then I've got the 1,200 over the 7. That's what you see there. Solve this for x, and you're going to get 6,588.7. Remember, that's not the solution. That's just the distance here. From how far is it diagonally from the first viewer, Matt, all the way to the top of the mountain. And then at that point, I've got sine of 35 equals h over that hypotenuse, right? We got a big right triangle here. You can see it down here, kind of extracted it out. And so the sine of this angle is equal to the opposite over the hypotenuse. And you see me plug that in just here and solve for h, which gives us the 3,779.1 feet tall. And that's it. Here we're going to look at a question that we posed in class today. It's a good question. It's fairly detailed, so I wanted to go over it with you. Rock climbing question. So you have a climber on a rock face who's looking back in the distance and seeing a mountain, Gray Mountain, off in the distance. And we know Gray Mountain is 2,000 feet tall. We also know that the angle of elevation is 42 degrees for the climber up to the top of Gray Mountain. To look at the base of Gray Mountain, he has to look down at 36 degrees. The question we want to know is how tall or how high is the climber off ground level, right? Now, something to note is that a lot of people want to take this value, they want to cut this distance in half, say the top part's 1,000 and the bottom part's 1,000. That'd be great if you had any reason to do that. It's not drawn that way. It's also not accurate. If this is exactly the same, then the angle here and the angle here would have been exactly the same. He's got to look a little farther up, so he's not quite at halfway. He's actually a little bit below halfway. So that doesn't work. We need to find a way to figure out how high the climber is from the ground. What we do know is we have one gigantic triangle, and we know that this full angle here is the sum of those two. You're going to get, this is a 78-degree angle. And if I could, that would be great. I have these little right triangles at the bottom here. If I could find out, let's call this y. If I could find y, I think I could be able to solve for x. I know that I've got parallel lines, horizontal lines, this one and this one. We know that this is going to be 36 degrees because alternate interior angles, because we have the one here for 36, right? So this one's going to be 36. So if I can get y, I could use sine to find x. So I'm going to set up a triangle. I'm also going to need the angle at the top of the gray mountain. So if we look at that, that's going to be, we're going to subtract 90 minus the 42, which is going to be 48. And so we're going to make sure that gets placed in the top. And that's going to give us enough. And I'm looking at the triangle, this larger triangle. If we kind of look at that, it's this big triangle here. We have a full angle, we have a full side, I have another angle, and I'm missing a side, right? So this is going to be a perfect law of sines question. So we're going to set it up. We'll say y, let's do this in white. Y over the sine of 48 is equal to, of course, 2,000 over the sine of 78. Now we're going to go ahead and we're just going to solve for y. So we're going to do 2,000 times the sine of 48 divided by the sine of 78. This gets us the y is equal to 1,519.5 feet. So I know this one is that value here, so 1519.5. That's easy enough. We're just going to go ahead and do traditional trig. Sine of 36 is equal to the missing x height, the opposite side, divided by the hypotenuse of 1519.5. So we're just going to do 1519 times the sine of 36. That's going to give us the total height of the climber off the ground, and that x is equal to, let's see, 893.1. And that's how we would get that. So this is kind of a two-step problem. Just kind of recap it real quick. It was nice to assess all the pieces I had. I obviously have a right triangle here. I've got a right triangle there. But the problem with just using these smaller triangles is that I didn't have any side lengths at all. I had angle measures to go all around, but no sides. I did have one distance given, and it was this one. So since this is my distance, I had to use this full triangle. It was nice that I had the opposite angle, and so I could use the law of sines because I had a matching pair here and here. That allowed me to find this one, which I also see that I've got a right triangle here. By the way, this height here is exactly the same height here. So if you found this side and realizing it would have been the same, it's the same exact problem. If I were you, I would try this question. You maybe pause the video and write down the question and try it for yourself without looking at what you've already seen to see if you can reproduce it.